Hello everyone and welcome back. So this is the fifth video in our tutorial series for creating a simple space shooter. And so far in the previous four videos we have engines and we can fly our player ship like this all through outer space infinitely. We've set up the player script control for flying the ship. We've set up a fake star field around the player so it looks like the player is actually traveling through space at a certain speed. And we've set up a pretty cool Space Nebula skybox in the background. But today is going to be the fun part, which is shooting. So for simplicity's sake and teaching, we're just going to shoot out some lasers that are going to hit some boxes that will represent AI, and it's going to damage with the health on these boxes until they get destroyed. In a future tutorial, we're going to build on top of this with a little bit more of a complex projectile, like a homing missile. It's going to kind of shoot out until it senses an enemy AI that's close within a distance range, and then it'll seek that out and basically travel after it at a certain speed until it damages it or destroys it. So when you're thinking about setting up shooting on your player ship here, obviously we're going to need a script to allow us to take input for shooting and shoot out that projectile. But the first thing we're going to need is something to shoot. So basically, let's start working on setting up a projectile. Okay, so we're going to go game object, create it empty. Actually, I lied. No, we're not. We're going to go game object, create other. We're going to create a sphere. Okay, so we don't need the mesh renderer. I'm going to go up here and we'll just hit reset. I watch a lot of tutorials. I just want to mention this as a side note where I see a lot of devs in here manually zeroing out the transforms and things like that. That's what this Unity put this little reset button in here for. It's pretty cool. And if you have data in other fields like this and you don't want to reset the scale or something, just reset its position. Okay? Or just entirely reset. So this is going to represent our little laser traveling out, our little hot beam that's going to hurt the enemy. So right now it's actually quite a bit too big. So let's make it a size that we think is decent to, or it's not impossible to strike the enemy with it. So let's look at our player ship as an example. This looks pretty good. So if you're not 100% accurate, you could miss by a hair like that. Or if you're aiming dead on, you could hit him in the wing, fuselage, etc. So, oops, see, I did it myself. I reset the scale and I like the scale. So 0.34, that's good. I'm going to hide the player for right now so we can see what we're doing with this. So on this, we actually don't want anyone to see this little ball. So we're going to right click, remove component, and we're just going to remove off the visual. We're going to make our own visual for it. Okay? So let's just call this laser, and let's start saving what we're doing here with it as a prefab. So right click over the prefabs and create a prefab called laser. And then we just drag it into it. It'll turn blue. That means it's applied. Okay, hit apply. So now we need a visual so that, I'm going to move this out of the way, so that the player and the other players in the game and stuff can see, well, if it was multiplayer, they can see this projectile traveling through space. Okay? So we want to create empty, and we want to zero it out. Okay, and we want to drag it inside the laser, and we're going to call it trail, and it's going to be like a laser beam trail. Okay, we'll hit apply. Alright, so now on to the next thing. I've got a little texture in here. It's very tiny. It's just a little green beam. I don't think I can zoom in on it anymore. But if you look in the video description right now, pause the video, whatever, and go in there, there'll be a Dropbox link to just immediately click on this and it'll download it. Navigate to where it is and just pull it into one of your asset folders. Or if you have your own little texture, that's fine too. You don't have to use mine. So let's right click in Art Assets and create material. I'm going to call this laser trail, pretty appropriate name. And let's drag our laser beam texture into it. And then laser trail, we'll go ahead and make that mobile particles additive. I like to use the mobile shaders because usually they have most of the functionality of the PC shaders and stuff like that, but they're more optimized. So on our trail, let's add something to render a visual, which is going to be component effects, a trail renderer. Now trail renderer is pretty cool. It's lacking a material. So if I drag our laser sphere, you're going to see what a trail renderer does. It basically leaves a trail that billboards. So everywhere I rotate, you get to still see the trail, which is pretty handy because sometimes if you're like directly behind it, the trail would be invisible or invisible to other players. So trail renderer is very handy for a situation. It's pink or magenta like this by default because that's basically what Unity shows when it says you don't have a material on this mesh or this object. So it defaults to this hot pink. Let's drag the laser trail we just created into the material slot. Hit apply. And now we have a laser trail. Okay, neat. And the problem with this is though, it's our laser trail. It's a little too big. So you could do a few things. On the end of it, you could actually make it look a little, I don't know if we see this in the, yeah, we see that. Okay. Or you could make it, what I tend to do is I tend to make it a little bit smaller as if it were fading out like that. And that's pretty perfect. Now time, okay, this is neat. If I'm going to pull it along, okay, so it's a very long trail. And honestly, I don't want the trail that long. So the trail renderer works in a way that this time factor is how long in time over frames in your game it'll let this trail stretch out. Well, we don't need it to persist for 5 seconds. So we can go just 1. What I'm going to do is reset the position on this. Now trail renderers work over time. Reset the position on this. They work over time. I'm going to hit apply. So it'll persist in the scene like that. They look kind of wonky in the scene like that. So see, now it's zeroed back out. And if I drag it, our trail starts kind of fizzling out and ending a lot sooner. It's actually still a little bit too long. Let's make the time short, like 0.35. Okay, everything is hit apply, zeroed out. Let's drag it back in. That'll do. That'll do, pig. That'll do. I don't know if you guys know what movie that's from, but I'm sure you do. Okay, so that I'm going to delete it and pull it back out. I don't want to see the trail render in there like that. So this is our projectile. When we fire it, we'll see a trail behind it. We do want to be able to detect collisions with other things in our world, so we're going to need to add a rigid body. Okay, something important that took me a year and a half or 2 years working with Unity until I discovered that if you're moving anything in the world and it has a collider on it, it needs a rigid body on it. Okay? Only static things that will never move in your world, like level geometry that'll never move and the collision for it, that doesn't have to have a rigid body on it. But things that move do. The reason for that is if you try to move something like this projectile through space without the rigid body on it, Unity assumes without a rigid body on it, it is a static collider object. And I don't mean checking the static tab up here, but it actually thinks it's an object that never moves and is static in the world, and it doesn't have to do any further calculations other than when the scene starts up for the collision on it, okay? Whereas if you're moving an object with a collider, and it's not static, it's moving, then Unity says, oh no, this is actually a dynamic collider, and so it goes through the entire game scene and recalculates collision for all of your colliders in your scene, static and non-static. So anything you're moving, in your world needs a rigid body on it. Now, you can also check is kinematic, and that'll allow you to move things but not use the physics with it, and keep the rigid body on it to let Unity's physics system know this is not a static collider, this is a dynamic one. We're not going to check is kinematic on it. We do want it to bump into things like a ship or a box or something. And we're not going to use gravity because well, we're shooting it out and it's not going to have gravity like it's on Earth. So that should be about it for our projectile. Well, one last thing. When we fire it away from our player also has collision all around it. So when it comes out of it, sometimes you can have weird effects where your bullet will actually detonate on your player and damage your own player. And we don't want to do that. So what we're going to do is we're going to separate using collision layers. So let's create a layer for our player and actually put the player on that layer. Yes, change the children. And then for our laser, let's just create one called Projectile and then put Projectile on that. And it used to be in the past you had to script out layer masks and things like that to avoid that. But right now we can go and edit project settings, physics, and we have here a layer masking functionality in the physics manager here. So basically what's checked on says that these things down here, up here, can collide with these things here. So if we don't want the projectile and the player ever to collide together, we find the projectile line and the player line, and we say, well, player and projectiles collisions will never be checked against each other, and that immediately solves all that masking and stuff. We can also, if you just hover over the arrow, it'll tell you what it's linked to. So in this case, a projectile could collide with a projectile. We're going to have a firing rate, so projectiles aren't going to instantiate out right on top of each other. It's not an issue. And plus, you might want to keep this on just in case an enemy or another multiplayer player shoots a projectile out, and you are the most skilled player in the world, and you shoot their projectile with yours. So, not likely, but we're going to keep that collision check in there. So, we're going to hit apply. We have everything we need on our projectile. So let's start creating a script for the player that's going to allow us to shoot projectiles. So let's go right click on the scripts folder, C#, and we will call this, oh, my caps key, I just hit it. We call this player shooting. And then of course, let's find our player and left mouse drag it on and double click to open it up. We're going to get into mono develop. Okay. So the shooting part of scripting is usually always pretty darn simple. Unless this involves like multiplayer, it gets a little more complicated, but and as always, sometimes this class name right here will not match the class name here for one reason or another. Just make sure they match or you'll get errors. Okay? So we discussed in earlier tutorials what variables were and the different kinds, floats and ints and arrays and things like that. And we discussed public variables versus private variables. Private are hidden in the inspector, and public are visible in the inspector, and we can manipulate them and drag things into their buckets or slots. So we need variables, just a few, only like 6 or 7. So let's start with our first one. And I'm not going to tell you what it's going to be, because I'll let you look at it and we can figure out what it might be. Okay, so it's a public variable. I'm going to hit Control S, go on our player, and therefore we see it right there, okay? Alright, so what that variable is, it's a float, so it has a range of values, floating decimal points. Okay, it's called cooldown, and what it's really going to be is a timer that's just going to say when we fire, let the weapon cool down for this amount of time, and then recharge, and we can fire again. Okay, which is tied directly to this next public float called fire rate. Okay, I'm going to do something I didn't do in my tutorials earlier. I'm going to zoom in for you guys. And as always, it's always good to strictly type out what this is. I know we said it's a float right here, but usually when you're putting float numbers like that, we'll put a little F behind them. Okay? Now the fire rate is actually how rapidly, Control S, we'll go back, how rapidly the player can fire their weapon. So we want to say every half a second, 0.5. Okay, let me remove that. I don't know what that was. Sometimes I I do a setup ahead of time to test how a script works and everything. It's already written out, and I'm testing it, and then I don't remove some references to it. So fire rate. Cooldown, actually, we will never manually set, but I keep it public in the inspector so you can kind of see how the cooldown time is working, but eventually we'll make it private instead of public and hide it. Okay, so I'm going to do 2 forward slashes for code commenting because we're going to make a comment to let someone else know what this part of this variable in this script does. So we're going to say checks to see if we're actually firing. And this is a public bool is firing equals false. Okay, a bool is a boolean. It's actually written out as boolean in Unity script, and it's just called a bool in C#. And it's an on-off. It's a 0-1. 0 is, this is false or off, and 1 is on or true. Okay, so is firing is false. We're not firing. Okay, so the next thing we're going to code comment a couple of forward slashes, and we're going to say firing Haunt transforms for launching projectiles. Okay, so let's type the first one. Public transform left fire point. Okay, so what these are is we want a spot on our aircraft that we can move it around. I don't want to fire projectiles from the center of this aircraft like this. I actually want to have some spots here on the wings or under the wings or even on top of the craft. It all depends on what your 3D model is like, where these lasers are going to fire from. Okay, so we want to be able to drag in a transform, a point in space, an empty game object's transform into here and let it know this is where the left laser would fire from. Okay, we're going to hit Control C and Control V because we want to save our hands from carpal tunnel, and we need a right one. Very simple and easy. That's where the lasers are going to shoot from, left and right sides. You could just use one if you wanted, but it looked cooler to have lasers coming out of both sides of the aircraft. Okay, so the next one is I'm going to code comment our projectile object. And this is actually going to be a public variable. We want to drag it into a slot in the inspector. And it's just going to be a very generic type of game object. Okay, just a game object. And it's the laser prefab. And that's actually it's actually this prefab that we created right there. Okay, that's it. Game object. We haven't created the firing points, but we can. Let's do that. So game object create empty. Let's reset that bad boy. Let's drag it into our player. Let's call it fire points. And I'm a nut, you'll notice, for keeping hierarchies. Control D to duplicate it. Keeping hierarchies nice and neat and very well named. All colliders and little folder called colliders, all the visual effects in there. So let's left mouse drag those two into the fire points. And call this one left fire point. And we'll call this one right fire point. Okay, back on our player. Let's drag the left one into the left. Let's drag the right one into the right. Sounds like something off of Sesame Street, doesn't it? You put the left hand in, you put the right hand. I don't. And in the z-axis, let's move these forward. It's just 3.55. That's good. Let's move the right negative 1.6 over, and then the left exactly the same amount, 1.6 and positive. Let's hit apply. Now they're empty transforms, all they are is transforms, so we don't actually visually get to see them, which is kind of confusing a little bit. We don't want to actually see them in game, but in the editor it would be nice to see them. So we can always keep track of where they are when we move them around, and we say, oh, I want my firing point up here. How I did that is I just click this little thing, and Unity has these neat little built-in little tags and things that you can just assign kind of an icon to them. So there they are, and they scale up too, which is sort of annoying. sometimes. So we have our left and right firing points. We hit apply, and they're in. And we have a projectile. We have almost everything we need to start firing. Okay, laser prefab object. So the next thing we want, and I don't actually, well, I'll find one. Let's go public audio source sound. What do you want to call this? Fire effects sound. Okay, so and this is another assignable type of object, and it's going to ask for an audio source. So we could try to drag different things in there, and it wants a type of audio source. So we need to create that. And basically what it wants is the fire effect sound effect now. What sound are the lasers going to make when we fire? So let's go in and create a empty. Let's reset it. Okay. Or better yet, let's not do that and say we did, and let's just go component audio source, and let's just assign it on one of the firing points. I don't think we need it on both. Okay, so we don't want to play on awake, and we don't want it to loop, and we don't have a sound. So let's create a folder, not inside the script folder like I just did, and call it audio. And then I'm going to go look and I'm going to go grab a file I already have, which is called laser shot. Just find a piece of audio that you have on a hard drive or something and find yourself some kind of little sound. I don't know why Unity keeps bringing back that empty. Here. Why is it? Something. If I closed my editor and reopened it, it'd probably stop referencing that. But so it's a little. I don't know if you guys can hear that. It's annoyingly loud. But just find yourself freesound.org, even on gameart.org. I believe they have sound effects on there too. So find yourself a sound effect for that. If you don't have it, it's fine. As long as the audio source is applied, the tutorial can move forward. You will not get errors in your game if there's no piece of audio in the audio source. You will get an error if the audio source isn't applied. But it's there. So we put it on our fire point. Let's just drag it in and hit apply. For this tutorial purposes, I dragged in a little laser shot. But you don't have to have it. It won't error out. So let's get back to the script here. Okay, so that's it for our variables. Okay, now we're going to go in the start method, and I'm going to enter and give us spaces. As we've talked about before in prior tutorials, the start method is run when you hit the play button, and then it's done. It's called that one time. Whereas void update down here, this method, is called every single frame, once per frame of every frame of your game. So some things we just want to do once when the scene starts up. And for our case, we've already set is firing to false up here. I'm going to select that and hit Control C and V. But it's always a good idea as a sanity check or something. When the scene starts, just make sure it's set to false. We don't want to be firing when we hit play, just immediately after we start playing. So we're done with start. Now we need to get into our update function. So this is going to process things like physics movement and input on the keyboard or input from the mouse, things that happen every single frame. So one of the first things we want to do is we want to check for input. So I'm going to make a method called, in the Unity script, a function called check input. I'm going to enter some spaces down here, and we're actually going to create this custom method here for check input. We're going to make some brackets because we want something to happen inside this function. Okay, so we're calling it every single frame and update. And so we want to check. And for the purposes of this tutorial, we're going to make it real simple, and we're going to ask a question and say if input.get key down space. Then we want to do something. If we answer that question, the if, we want to say is firing equals true. So very simple logic in here so far. Update function's running every single frame of the game, and it says every single frame check for input. So we're saying, all right, let's check for input. Now, if this is the case, and the spacebar key, this is internal to Unity. The spacebar is called space. That's its key mapping on the keyboard. You can change this, customize it. So you can look into Unity's documentation on input, get key down, and look at all the ways you can customize. So we don't have to use the spacebar. It could be the tilde or asterisk key or something. Anyway, we're asking a question, and then we're giving an answer if it's true. So we're saying if the spacebar key is down, then is firing is true. And then we're going to say, well, what occurs if the spacebar key isn't down? Else. Some brackets, because this is what we want to occur in here. And is firing equals false. So we say if that key isn't down, we're not firing. So that's a pretty complicated method, and I'm being sarcastic because it isn't, right? It's pretty cool. So let's go back up into update here where we're checking things every frame. I'm going to put a space just for readability. And let's set some other things. Let's look back at that cooldown, and let's give that an automatic value and say cooldown minus or equal to time dot delta. God, I can't spell. Okay, so what that's saying in update every single frame is the cooldown time is going to be minus time.delta time. So it's actually going to decrement in time over time. Okay, so it's just going to keep counting down. Okay, so all that does is it makes cooldown become a counter. Simple terms. All right, so let's do a check here and say if is firing, and some brackets because we're asking this question. Well, are we firing? Okay, so this is like shorthand. This is if is firing, which basically means is firing true. And if we were going to say it shorthand false, we would say is firing not true. Now, this is programmer shorthand. You could write it the long way, and you may see it written somewhere, some other places, but you could say the long way. If is firing is true, if is firing is false. Okay. Honestly, I don't mind doing a little extra typing, just to really kind of see it written out. If is firing is true, I mean that's really straightforward. Whereas if it looks like this, I mean I know that that means it's true, but not everyone would. Okay, let's comment some code with some forward slashes and say the player has initiated shooting the laser right now. Okay, and underneath this comment, let's call another function or method. And see, oh, I hate code completing sometimes. Let's create a new custom one. And call it simply fire. So here we go. Checking the input, setting a cooldown timer, and we're asking a question if firing is true. Which, down here in check input, which is occurring earlier, we're setting is firing true or false by checking for the key, spacebar key on the keyboard. So the logic and everything all works out nice and neat. So for the last custom method or function we're going to need in here is this custom one we just made. Control C, paste, and some brackets to make something happen magical, and a little space for neatness. So void fire. This is where we're saying if the is firing true, let's actually fire something. And we're going to ask a question right away in the firing. And this is to prevent a player from spamming the fire button. We need to use that cooldown and the fire rate stuff to basically say, let's not let them spam it and hold it down and make an infinite amount of bullets into the world or lasers. So if our cooldown is greater than 0, and let's do something. So if the cooldown hasn't cooled down yet, let's do a return. And we're going to comment this and say, do not fire a thing. So this is pretty simple. The first question it's asking when you've initiated firing here by holding down the spacebar, it says, hey, if that cooldown timer is greater than 0, it is not cooled down, the weapon's still hot, return. Which return, we've discussed in other tutorials, just returns it to the top of the fire function again and loops back on itself and says we're not going any further into the function. Just keeps looping back until this is not true. Until cooldown is not greater than 0. It's equal to 0 or less than it. So the next thing we want to do is, assuming we've cooled down and we're ready to fire, let's ask another question. And this question we're going to ask is going to be a section for play the sound effects when player is firing. And we need to do a check. Another question. If sound, fire sound effects, that's it, is not equal to null, then do something. Too many gaps, it's not very readable, is it? Fire sound effects dot play. Okay, so the very first thing we do is, assuming that we've cooled down and we're ready to fire, let's move into this. Then we ask, well, if our fire sound effects is not equal to null, and remember in earlier tutorials we said, and we'll look here and explain this, this is not null right now, this audio source, because it's filled in the box. If it's set to none, none is null, empty. Okay, pretty easy. So we need to ask the script before we even try to access that audio source for the firing. Is the fire effects null? Well, we're actually asking, is it not null, which means it's there, it's assigned, then play the sound effects. This is going to prevent the game from basically freezing up and crashing. Okay, let's move on and actually do the firing. So we play a sound effects, and then the next thing we want to do is take a type of game object, instantiate, and I believe it was called laser prefab. That's the object. Fire point. We'll explain this in just a second. Fire point. Let's expand this window. There we go. Left fire point rotation. Close it out with this little brackets. And we want to fire 2 lasers, one from both wings. So let's instantiate another object, but this one we instantiate at the right fire point. Okay. And then let's take the cooldown because we fired, and let's set it to the fire rate. Okay, and let's close these empty gaps. Okay, so what happened in here is we passed this check. There is a fire sound effects audio source there. Let's play the sound and then move on down, and let's instantiate that game object up here, laser prefab, which is a game object. Let's instantiate it out into the world. Okay, and what we're going to instantiate is that laser prefab. Okay, that actual object up in the variable. And we're going to create it in the world at the left fire point's position, which is this position, or the left one. And we're going to give it the rotation of that firing point too, because we could technically take these firing points, and right now they're perfectly straight, but we could angle it and then it would fire out on that firing point's rotation. But we want it to go straight. And then do the same thing a second time on the right firing point. Another laser, 2 lasers on the left and right sides. And then this is the fun part. This is what sets the cooldown. After we fired, set the cooldown to the fire rate. Remember, the cooldown is a timer. It's just going negative, negative, negative from 0 in time. But right now, we're saying we just fired. Let's give it a value. And that's where the fire rate comes in. So this fire rate says, alright, cooldown is now going to start back over again to 0.5 seconds, so you won't be able to fire until another half second. Now technically, we should be able to fire right now, but our bullets aren't going to move anywhere. We're just going to instantiate something. Oh, actually, let me not move in the world yet so we can see it in the scene view. Okay. So they're there. But and they're actually traveling, which is odd because they shouldn't be traveling. They should be ignoring the player's collisions and collider. We can fix that though. Okay, so basically that's it. That's it for the firing part. We can fire, but they're not firing properly because the ship is actually not giving the projectile any kind of velocity or movement or anything. So nothing is telling this laser beam where to go in the world. So what we need to do is put a couple of scripts on the laser itself, the projectile thing. So let's go in our script folder and create a C# script and call it self-destruct. Now, this is going to be a neat little script. It's pretty short, and we're going to apply it onto the laser. And what this script is basically going to do is it's just going to say, instead of this laser being able to travel infinitely out into space, it will destroy itself and explode when it gets a certain distance away, which is pretty cool because usually you do it when it's almost completely out of the visual range. And this way the scene doesn't keep getting cluttered with all these physics projectiles in the scene that aren't going away because they haven't hit anything. So we're going to create a public float, and we're just going to call it self-destruct time and set it to 1 float. And that is the single variable we need, and it's just a floating value that says this is the time that the projectile will be destroyed in. It'll destroy itself. And everything's going to happen in update. So let's just say the self-destruct time is minus or equal to time.delta time. Pretty neat, right? That's a countdown again. It's just saying whatever you set self-destruct time to, which is 1 second now, it's going to count down during the time of your gameplay. And then we'll ask a question. If self-destruct time is less than or equal to 0, then let's do something. And you can figure what that's going to be. Let's destroy the scam object itself. Okay, super simple script. Let's hit Control S and save it. So we're counting down self-destruct time from this 1 second float right here. And we're saying when it reaches 0, it's less than or equal to 0, destroy the object. So it's really just going to destroy it after this countdown timer. So let's go back into our projectile. And normally you want it to be destroyed like much longer than a second. It does need to travel out into space for a while and hit something. So let's say 4 seconds later out into the world. If it doesn't hit anything in that time, then you're pretty darn far away from whatever it is you're trying to shoot. Let's just go file save scene, file save project, and we'll continue on. I was going to go ahead and I thought we would continue on in this tutorial, but actually for the projectile script itself, so I don't go over 40 minutes on this, the projectile script is only about 45 lines long, so we're just going to do the projectile script in part 2 of this tutorial. So right now, let's just show you that the projectiles, okay, so they're out there and it's counting down and they get destroyed. So scene gets cleaned up. Okay? I know what's happening with the projectiles. They're not actually colliding with the player. They're bouncing off of each other. I just figured it out. So, and to prove that, project settings, physics, if we turn off projectile and projectile collision, this is going to be neat. And go in wireframe. Yeah, they're not moving at all in the world. So we don't see the trail renderers. Like if I was to do that, we'd see it. They're not actually moving out into the world at all. They just get instantiated and spawn there. So let's keep that masking going on. And so I'm going to start tutorial 2 right now, and we'll move right into that, and we'll get our projectiles actually flying out into the world. We'll also do our health script at that same time. So I'll look for you in part